because one of the most important things you got to come out of this class with is an understanding of how to attack basic integrals. I can't let you go to the next level or leave this course if you don't get that. So for example, one thing that had me troubled on the quiz, a lot of people did fine. The U-sub went a little bit freaky, so that's why I want to devote most of my time there, but some of the other stuff went a little freaky too. For example, there's a problem that looks sort of like this. I can't remember, did I make it with, yeah, sure. So we'll do from, sure. Yeah, exactly. So there was only one person that, and this happens sometimes, just started plugging stuff in. Right? You can't do that until you've taken the antiderivative, right? You need to find the antiderivative. Some other people plugged it in but never put it all together. What's the answer to this is a number. I want to know the area under this curve from there to there. So it shouldn't be two separate answers, right? It's got to be an answer, one answer. So like John said, if you first find the antiderivative of this, and what I thought was an anomaly, I saw somebody did that, just didn't put that there at all, and then a few other people did the same thing. I'm like, oh shit, we're taking an antiderivative. So this doesn't disappear. That's derivative would make that disappear. This becomes 4x, right? Okay, cool. So a couple things happen. I want to make sure they never happen again. Now I'm going to do this, and then I'll show you a shortcut for this one. Well, we'll see. For this one, there won't be a shortcut, but I do have to address symmetry a bit. This one I didn't really make symmetric like I was thinking about, but oh, too bad for me. So now you just plug and chug, right? Basically, you're doing this. You're doing the f-talk. You're doing f of 2, the antiderivative evaluated at 2, minus the antiderivative evaluated at negative 2. There were some people turning that around. It's always, and I think it was Pablo that pointed out, my little song works again. Come first. Right? You always do the top one first, bottom one next. Yeah, so now you just plug and chug, so you get 1/4 of 2 to the 4th. 2 to the 4th is 16 divided by 4 is 4 minus 8 minus, and there were some problems with the negative here. You got to be careful. You got to subtract the whole damn thing. And when you plug a negative 2 in, again, you get 16 divided by 4 is 4 minus, this becomes plus 8. Oh, I get plus 8. So you get 4 minus 4 is gone. Negative 8 plus, negative 8 minus 8 is negative 16. Cool. Notice how, well, if the question was this, there's a shortcut to this. Because what does x cubed look like? I like it. Cool. You guys are awesome. I love that. I was like, has anybody got yes? A lot of them people. So it's the thing that one of my colleagues calls a giraffe graph. Because he says it looks like a giraffe. And I'm like, he doesn't have a front leg. What the hell happened? He's that's a little morbid. But I like to make fun. So it's going to be, so if I go from negative A to A, this area is going to do what to this area? Cancel it out. And we actually saw that happen. This 4 and that 4 canceled. Was what came from this. So what kind of symmetry does this guy have? Odd symmetry. So if it's got odd symmetry, and you go from negative A to A, negative 7 to 7, negative a million to a million, then it's going to be 0. I like it. If it's evenly symmetric, that's the one we've seen already. If it's evenly symmetric, then you can just, an integral from negative A to A of an even function would be twice the integral from 0 to A. We've seen that already. You've used that before. Do you ever have to, ever in your life use either one of these things? Never. There's at least one homework problem that's impossible to do without this, though. It's just this weird conglomeration of x cubed and sine and bullshit. It's an odd function, so the answer is 0. But if you try to attack it with u sub or something, you'll go insane because it's basically impossible to do. You have to realize it's an odd function. So whenever you see integral from something to its opposite, you got to think, okay, man, is this a trick one? Do you want me to realize what kind of symmetry it has to get the answer? You guys cool with that idea of symmetry and how it affects? Yes? Okay. All right. Okay, what was the other thing? Oh, well, all right. So there's several little things there. Now let's talk about u sub. And I don't blame you guys for not completely trusting u sub. When you're dealing with something that's new, integration, and then I teach you something that makes things look better, you distrust it. You're like, this can't be right because integration is hard. I know it's hard. Because I noticed some people were trying to figure out what the answer was going to be, thinking about what it used to be, but all that is crap. You take whenever you do your u substitution, you just integrate that. Let the process work. You don't have to come in there and guess about anything. What the hell am I talking about? Well, so if I had this, what did I put on there? Did I have it? Yeah, I sort of. Okay. We'll use this then. I think I did this example once before, but. Alright, so there's that. So can somebody explain to me why this is screaming use u sub?
There's part of a derivative. There's part of a derivative.
Yeah, there's a function whose derivative is in there.
Yeah.
And also if it was just that, it would be easy, because I know what the integral of secant squared is. Tangent. Kick ass. So there's a very easily identifiable inside function whose derivative is in there, except for the constants, and we can make the constants work. So help me out here. What did we learn yesterday? What's a good first step?
Figure out u.
All right, cool. So we can figure out u, and what's u going to be?
5x cubed minus
5x cubed minus 7. I like it. Now, I had a couple people leaving off the dx at the end, and that got one person in trouble. They or two people actually left the dx inside. What we're really doing here is we're doing du dx, like always. That's like we used to do, except we're just multiplying the dx up on the other side. And we see that's called a differential. So, of course, what's the derivative here?
15x squared
dx. So that's important to have there. So if I saw 15x squared dx up there, I could replace that with du. That's it. Because I know this is true. If this is true, then this is true. Why is this true? Because I said so. Damn it. What can we do in algebra, math, anything that uses variables? Well, if there's a part I don't know, I can call it a variable. And this feels like cheating very often. How is it possibly cheating? I don't know what 5x cubed minus 7 is. I'm going to call it u. I don't know how much money Bob made. I'm going to call it x. Right? It's the same idea. And then you can follow, well, what's the implications of that then? Well, then that means du must be this. Right, maybe. So I currently see freaking 4x squared dx. That sucks.
You can do 4 out.
Yeah, take the 4 out of the way. It's nowhere near what I want. So take that 4 the hell out of the way. And then how do I get a 15 to show up there?
Put 15 in the right place.
Yeah, if I put a 15 there, I better
Alright.
divide by 15. 15, Chad. Let me stop there for a second. This happens like 90% of the time with u sub. This is your classic u sub steps. Identify the inside function whose derivative is in there. Okay, then let u be that, find its derivative. Okay, now make the constants work. Now we're at the step where we just replace. We've built everything that we need. Now we just replace everything. So what can I replace this with?
du.
Yeah, so that is now du. It just is. Why? Because it is. Right? I don't get to say that very often, but if that is true, then this is true. That's All there is to it. And then what can I write this as?
Secant squared is
Secant squared u, kick ass. So again, I did this, I can't remember if I did this in class or if I just did this. We're not quite done with that yet, but real quick. I think I did this in class, but I can't remember. What's the derivative of this?
secant squared.
Secant squared,
7x to the 4.
7x to the 4th,
28x.
times the derivative of that, 28
X cubed.
x cubed. Right, so if I say this is y, then dy equals that dx. Is that cool? Let me stop there for a second. That's fine. Derivatives now are relatively easy. You're like, man, what was wrong with past me? Please, I want derivatives. Nothing but derivatives, Jeff. But look here. What is this? Well, if this is u, what's du? That's du. That's the chain rule. That's one way that they showed you how to do the chain rule, is to use that u for a second, just to kind of tell yourself what the inside function is. So all I'm doing here is I'm doing that backwards. I'm identifying what my du must have been. Right? And then this, is whatever the hell. So this becomes, this came from the derivative of the inside. So if I just call the inside u, this would have to be du. That's where it would have come from. That's the chain rule. So I'm using that fact backwards. That's why you have to trust the process. I think some of you guys just don't trust the process. I don't blame you. It does make it really pretty easy right now. It should. The integral ends up being remarkably easy. And this is when people started to try to bring stuff back in. No, it can't be just tangent. I got to have a 5x cubed in there. So it's 14, 15, whatever. No. You get 4 over 15 times tangent of u. And u was
5x cubed
5x cubed minus 7. Plus c. Kick ass. So you don't have to bring back in here like 15x squared. I mean, that's gone. Right? I get that feeling that a few of you guys are trying to bring more stuff into it. No, you do exactly what it says. Do that integral. It's du, so who gives a shit about x? This integral doesn't give a shit about x. It's all about u. Right? So you say, damn sure it's all about me. Right? And then here's where you bring back in what u was in terms of x. Because your question was about x, your answer better be about x. Or maybe. And how do you check yourself? Take derivative. Which should be something you could do in your head. Right? When there's be secant squared of crap, derivative of this stuff would be 15x squared. The 15 cancels, you get 4x squared. Holy shit, there, done. Bam. You don't have to actually do the whole thing. Just kind of quickly make sure that you get what's there. If you can't do it in your head and you got time, don't do it in your head. Do it on the paper, it's no big deal. That's how you check yourself. Okay, maybe. Alright. Well, let's just see what the hell happens. I want to give you guys this here. Go ahead and work alone or together. It's up to you. Tuesday equals Tuesday. Jason, is he doing it?
You told me yesterday to grab one extra one.
Do all of these?